Hello and welcome to this learning video. In this learning video, we are going to take the application part of the Laplace transform. And in this application of Laplace transform, there are 3-4 subtopics that we have to learn. One is the application of Laplace transform to higher order linear differential equations with constant coefficient, application to integral equation, application to integral differential equation, and also the application of Laplace transform for simultaneous linear equations. So these are the topics that we are going to learn, and the very first topic here in this learning video that we are going to discuss is the application of Laplace transform to linear differential equation with constant coefficient. Okay, so here in this under this application, we just need to remember this application, this property of Laplace transform of derivative. Okay, because we are going to make use of this. Another thing is you need to remember this. Apart from this, we have the working rule for this. So the working rule says write down the given equations and the given conditions. That is the very first step. The very second step says take Laplace transform on both sides. That is the step number 2. And after taking the Laplace transform, apply Laplace transform of derivative property as the case it may be. Okay. Sometimes we have to make use of this and this simultaneously, sometimes separately. And after taking the Laplace transform of derivative property, you just apply the given condition and try to get a simple function of s, and then at last take inverse Laplace transform to get the desired result. Okay. Now the problem that we have under this topic is this: solve y double dash plus y is equal to t, and we are given the initial condition y of 0 is 1 and y dash of 0 is 2. Okay, so what is the very first condition that we have to do is that write down the given equation. So the very first thing is that you have to take this equation, given equation, and write down the given condition. Okay, so I'm going to write down the solution here. So solution of this equation, given equation is what is it? Y double dash plus y is equal to t. Also we are given y of 0 is 1 and y dash of 0 is 2. Okay, so first step is over. Now what I need to do is I need to take Laplace transform of this equation. So you can write taking Laplace transform, I will write it as LT, taking Laplace transform on both sides, we get what we will be getting: Laplace transform of y double dash plus Laplace transform of y is equal to Laplace transform of t. Okay, here we are going to apply the property of Laplace transform of derivative. So how many derivatives are there? 2. So it will start with s square. So s square, Laplace transform of y, I will write it as y of s plus s into y of 0, sorry, not plus, sorry, it is minus y dash of 0. This is just the Laplace transform of this. Now Laplace transform of y is y of s, Laplace transform of t is 1 by s square. Yes, 1 by s square, right? Now you have the values, so put these values over here. So you'll be getting s square y of s minus s into what is y of 0? It's 1, y dash of 0 2 plus y of s is equal to 1 upon s square. Now you can collect the like terms, that is s square plus 1 y of s is equal to 1 upon s square. Take these term to the this right, so this is plus s plus 2. Okay, so it would be like y of s is equal to 1 upon s square into s square plus 1 plus s upon s square plus 1 plus 2 upon s square plus 1, and say this is to be equation number 1. Okay, now what I need to do is, now I need to take the Laplace transform, but here as you can see this is the complex fraction, so I need to get this as a linear this as a simple partial fraction. So I am going to apply here the partial fraction method. So writing this is as y of s is equal to, now I am doing this here partial fraction, so 1 upon s square into s square plus 1, I will write it as I will write it as 1 upon p into p square, p into p plus 1, and write it as a by p plus b by p plus 1, where what is this p? P is s square. For the sake of very convenient, very easily you can get this, so I am doing it. Now this is 1 upon p into p plus 1. Now linear factors are very easy to deal with. Okay, so to get the value of p, I will put p is equal to 0 in the left hand side, excluding this term. So what is it? A is equal to 1 upon 0 plus 1, that is 1. Okay, now to find out b, what I need to do is I need to put p is equal to minus 1 in the left hand side, excluding this factor. So it is 1 upon minus 1, so minus 1. So this 1 upon s square into s square plus 1 is same as, what is it? A is 1 by p is s square, plus b is minus 1, so minus 1 by s square plus 1. Okay, so I will write this fraction as 1 upon s square minus 1 upon s square plus 1 plus s upon s square plus 1 plus 2 upon s square plus 1. Okay, now you can see this term and this term are same, so I can combine this. So this is 1 by s square minus 1 plus 2 is plus 1, 1 upon s square plus 1 plus s upon s square plus 1. So this is my y of s. Now I am ready to take the inverse Laplace transform. So now taking inverse Laplace transform on both sides, I will be getting L inverse of y of s is equal to L inverse of 1 by s square plus L inverse of 1 upon s square plus 1 plus Laplace inverse of s upon s square plus 1. Simple. Now these are the elementary Laplace transform, so you can certainly write implies this is inverse Laplace transform of y of s is y of t. What is inverse Laplace transform of 1 upon s square? That's t, plus inverse Laplace transform of a upon s square plus a square is sin t, and this is Laplace inverse of cos t. Okay, so as you can see here that very easily we have found out this thing. Okay, so I hope the problem that I have taken here is clear to you. So in the upcoming lecture we'll take one more problem and one or two problem in the live discussion. Okay, so I hope this is clear to you, and for any queries or any doubt you can contact me. Thank you for watching and enjoy learning mathematics. Thank you.